All right. What better time than after the chain rule to take a pause for the cause and go back and take a look at some limits, specifically limits of composite functions. Some calculus books like to refer to these as advanced limits. They're AP's way of making limits hard. I bring them up now for two reasons. One, I like to talk about limits again every once in a while. Two, we're specifically talking about composite functions, which we were just talking about with the chain rule. And it's worth noting here that when you do these limits, we're going to work them the same way we work a chain rule. We're going to work from the inside out. So for this limit that they gave us right here, f of g of x, we got a baby function and we got a mother function. I'm going to do the limit with the baby function first, see what I get, and then I'll worry about the limit with the mother function. Okay? So we're going to work from the inside out. Ready? Okay, so the first thing I need to do is recognize that I have the limit of f of something. And I need you to always, always, always remember that when you check a limit, you are checking from the left and from the right, and they better darn well match. Otherwise, we have to say does not exist. Okay, but in order to figure out what number to put in here, I'm not necessarily putting a 2 into f of x. In order to figure out what to approach on f of x, I have to figure out what g of x is approaching first. So the first real limit that I'm going to do is the limit as x approaches 2 of g of x. If I can figure out what the limit of x approaches 2 of g of x is, that number is going to be the one that pops in here. That's the number that I'll use when I do the limit for f. I'm working from the inside out. Okay, now remember, when we do a limit, two-sided. So I'm going to have to approach 2 from the positive side on g of x, and I'm also going to have to approach 2 from the negative side on g of x. Okay, so let's take a look at our g of x graph. On g of x, here's 2, right? When I approach from the right, I get a 2. I'm approaching 2. When I approach from the left, I get a 2. Okay? So one might say, oh, okay, the limit as you approach, one might say, pay attention, Miss Burton, that's not a 2, it's a 1. It's a stinking 1. One might say that. 1, pun intended, might say, oh, I did the limit as x approaches 2 of g of x and I got a 1. So let me just go over here and plug a 1 into f of x. Oh, I got negative 1. Wrong. Or you might say, oh, that's right, I have to approach 1. And so you go to f of x and you approach 1 from the right and you get 1, and you approach 1 from the left and you get negative 2, and you go, oh, this limit doesn't exist. Wrong. Yeah. Okay. I'm not going to lie to you. I had to learn this the hard way. I missed a lot of these questions before somebody graced me with this explanation. It's a detail I never would have thought of, but it's an important detail. Okay. Check this out. When you are on g of x, when you do this limit, yes, it's true, it comes out to 1. However, it is important. Remember, we're approaching 1. And it wouldn't matter from which side we were approaching 1 if the only question was, what's the limit as x approaches 2 of g of x? If this were the only question, our answer would be 1 and we'd be done. The thing is, this answer from g of x is about to become another number we're approaching. Right? I'm going to take my answer from g of x and it's going to become the number I approach for f of x. In other words, the answer to g of x becomes what I approach for f of x. And therefore, I have to be a little more careful about what my answer is for g of x. Here's what I mean. When I approach g of x, when I approach 2 from the positive side, yes, I am approaching 1. But please note that we are approaching from above. In other words, the values that I'm actually going to carry over to f of x are all going to be values that are slightly bigger than 1. In other words, I'm going to be approaching I'm going to be approaching 1 from the positive side. Because as I approach 2 from the positive side, I come down to 1 from the positive side. And the same thing happens when you approach negative here. On g of x, when I approach from this way, again, I am coming from above. So I end up getting values like 1.1, 1.01, 1.001, etc., etc., etc. In other words, when I come over here, the value that I'm going to use when I go to the graph of f of x is a 1, but very specifically, it's a 1 as I approach from above 1. The values from g of x, the values that g of x spits out or generates, are only ever going to be numbers that are above 1, approaching 1 from up high, approaching it from down. In other words, every single value that g of x spits out will be close to 1, but it's going to be bigger than 1. So when I do my limit, when I come back to the original problem and I do the limit for f, so now I need to do the limit of f of g of x, but the thing I'm approaching for f now is 1, but only from the positive side, because those are the only values that g of x spits out. So when I come over to my graph, the fact that it approaches left and right, I don't care, because I am only approaching from the right, because I know that the only values g of x is going to spit out are these values up here. G of x is never going to spit a value out down there. It's never going to generate a number like this, so I don't ever need to worry about what's happening on that side of 1 for f of x. So for this one, we would say, okay, 1, when you look at g of x, it's approaching 1, but from the positive side, from above. So when I go over to f of x, I'm going to approach 1, but I'm only going to approach it from above. I'm going to worry about coming at it from below. And if I do that, I get a 1 for my answer. And that is the answer to this limit. Okay. That's a lot. That's a lot to think about. It's bad enough we have to remember to do the limit from both sides. Noting whether it's coming from above or below is a new layer. But again, remember, this is only going to be important if you're working with a composite function, because the answer you get for the first limit you do becomes the input of the next limit. And when your output of your first limit becomes input for a new limit, it becomes very important that we know if we're approaching from the right or the left or both. If we're approaching from both, then we got more work to do. Okay. Let's do another example. Okay. All right. All right. Same graphs. This time I have g of f of x and I'm approaching 1. All right. So let's take a look at f of x as we approach 1. You know what? I don't want to do it down here. Okay, so I'm going to do the limit of f of x as I approach 1 from the positive side and see what I get. And I'm going to do the limit. Oh, you didn't see that. And I'm going to do the limit as x approaches 1 from the negative side of f of x. So from there, we're going to start with our baby function. Okay, so up to f of x we go. As you approach 1 from the positive side, you get values like 1. But they're going to be the values that are bigger than 1. In other words, I'm approaching 1 and I'm doing it from above. So to denote that, I'm going to put a little plus up there. In other words, when I start dealing with g of x, I'm going to know when I approach from the positive side, I want to be approaching from values from above. On the negative side, when I approach 1 on f of x from the negative side, I'm approaching negative 2. But look from where I'm approaching. Here, it's all going to be values from below negative 2. Okay, so numbers like negative 2.01, negative 2.001. Again, why is that important? It's important because this is about to become the input of the next layer of this limit. So if I don't know from which direction I'm coming from, I can't possibly evaluate the limit of g of x because I have to know from which direction to come. So when you're doing the first layer of your limit, you got to make sure you note from which direction it is coming. Okay, so here's the thing. In the last one, I got a little bit lucky, and these both came out to 1 from the positive side, right? So when I went over to do my other limit, I only had to look at f of x as you approach 1 from the positive side. That's not happening here. Okay, so I've got 2 limits to look at here for g of x. First, I need to see what's happening to g as I approach 1 from the positive side. So let's go up here to g of x. G of x, I'm going to approach 1, but I'm going to do it from the positive side. Okay, I get 2. All right. Now I'm going to look at g of x, but from the left, I have to approach negative 2, but I need to approach negative 2 from the negative side. Important. Okay, so I'm going to approach negative 2. I'm going to approach from the left. And look what I get. I get 2. These match. Even though their input from the left and the input from the right were different, we still ended up with 2 limits that match when we evaluated the g of x, when we evaluated the whole function. So since these match, I have an answer. My answer is 2. These are crazy, aren't they? When you take composite functions and limits and combine them, it's like madness. Complete madness. Okay, so this was, I believe, on the paper that I gave you, these were numbers 1 and 3. So here's what I would like you to do. I would like you to take a few minutes and try 2, 4, 5, and 6. Just try them. And then come back and check your answers with me. Okay? Go take a moment and try those 4 problems. I'll be here. Well, how'd you do? I'm not fully certain my webcam's working, so I'm going to try not to talk with my hands here. Okay, here's the answers. Check and see if you got any of them right. On your mark, attack, go! Did you get them? Okay, I'm going to go over these briefly, one at a time, and hopefully if you didn't get them, you will figure out what you did wrong. I'm not going to lie, I missed one of them because I don't know how to read. On number 6, I approached 3 instead of negative 3. All right, okay, let's look at number 2 first. So in number 2, this isn't necessarily, well, this is composite-y, right? I need to do g of x minus 5, but it's not like I have f of g of x or something here. So this one's slightly different. So I need to do the limit, though, still. I'm going to be approaching 1 from the positive side, and I'm going to be approaching 1 from the negative side, right? So this is going to make a difference. So for this, when I approach 1 from the positive side, that's going to be f of 1 with numbers that are slightly larger, in other words, approaching from the positive side, plus g of, and we have to be careful here, if I'm putting a 1 from the positive side in here, numbers like 1.01, 1.001, and then I'm subtracting 5. The numbers I'm going to get are going to be pretty close to negative 4, but since the 1 was slightly bigger than 1, the numbers I'm going to get are slightly less than 4. So I'm going to be getting numbers like negative 3.9, negative 3.99. So in other words, I'm approaching negative 4 here, but I'm doing it from, and this is weird, the positive side. In other words, the numbers that this is going to pop out are numbers like 3.9, 3.99. They're negative. So on g of x, I'm going to be approaching -4, but I'm going to be doing it from this side. Okay, so if I flush those numbers out, f of 1 when you approach from the positive side is 1. G of -4 when you approach from the positive side is -2. You get a -1. We have to do the same thing, but we have to do it from the other side. So when I do that, f as you approach from the negative side of 1, we know is going to be -2. And we have to look at g again. Again, I'm going to put numbers like -0.9, -0.99, because I'm approaching 1, but I'm doing it from this side. Right? So my numbers are going to be approaching, I'm approaching 1 here, right? But then I'm going to do a -5. So my numbers are going to be approaching -4, but they're going to be approaching it from the negative side. In other words, my numbers are going to be numbers like 4.1, 4.01. So that's approaching from the negative side. To me, this feels a little backwards because I like to think of the positive side as numbers that are bigger. And in negative terms, -3.9 is bigger than -4, but it doesn't feel bigger to me. Right. So if I go here and I go up to the graph and I do g of -4 from the negative side, I get a 1, and look, -1. They match. So you have a limit. Okay. All right, how about number 4? Let's see. I have to approach 3 g of f of x. So again, this is like one of the ones we did on the previous slide where I need to figure out what f of x is doing from the right and from the left and then pop that into g of x. So the first thing I'm going to do is check out x approaches 3 from the positive side of f of x and x approaches 3 from the negative side of f of x. So f of x. As you approach 3 from the positive side, you are going straight to infinity. As you approach 3 from the negative side, you are going straight to infinity. So great news, f of x is going to infinity, and when it comes to infinity, there is no right or left, right? There's only one way to approach negative or positive infinity, and that's from below. So I'm doing g as you approach infinity from below. So let me go over to my g function and see what happens as I approach infinity. It's got a nice sweet end behavior down there at -2. -2 it is. So the f of x's are both going to infinity, so all I have to do is go over and look at my g of x graph and see what it's doing towards infinity, and it's going to -2. It has, I guess you'd call that an asymptote, right? Technically. Okay. Number 5. Whoa, I just shifted my desk. Okay, number 5. I am approaching 4. Again, this is similar to number 2, where it's not like f and g are composed with one another, but technically f of x minus 3 is a composite, and then these two are being multiplied, right? So I'm going to look at the limit as x approaches 4 from the positive side. Let's do that first. Okay, so that would be f of 4 from the positive side minus 3 and g of 4 from the positive side. So 4 from the positive side minus 3 is 1 from the positive side, right? It's a number that's a little bit bigger than 1. So when I go to f is over here, and I approach 1 from the positive side or from above, I get a 1. When I go over here and I approach 4 from the positive, from above, I get a 0. So this first limit is out to 0. 1 times 0 equals 0. Now I've already given you the answer, so you can probably imagine what's going to happen in the second one, but why imagine when you could do it? Let's go from the negative side. So if I go from the negative side, If you look at 4, again, approach from the negative side, you're getting a 0. Notice on g of x, it doesn't matter which side you approach 4 from, you're getting a 0. But, so it doesn't really matter what this is, but just for fun. If you're approaching 4 from the negative side, you're going to have numbers like 3.9, 3.99. Take away the 3, you're going to have numbers that are very close to 1, but from the negative side, right? So f of 1 from the negative side is your negative 2. Not that it matters, because you're multiplying it by 0. Again, these match, so we have a limit. The limit is 0. All right, last one. This is the first one we've gotten that doesn't exist. So I think this is an interesting one because it shows you how it happens that it doesn't exist. So don't be me. Read the problem correctly. So I have f of g of x, and I'm approaching negative 3. So again, this is a composite like this one was. So I'm going to start from the inside out. I'm going to work with the g of x first and see what g of x is feeding into f of x. So let me do the limit as x approaches negative 3 from the positive side of g of x. So here's negative 3. I'm going to approach it from the positive side, and what I get is 1, but again, remember, this is going to become input for f of x, so it's important to note from which way we are approaching. I'm approaching 1, but from above, so numbers bigger than 1. When I approach negative 3 from the negative side, from the left, from below, notice this time. When I approach negative 3 from the left, I'm still approaching 1, but I'm approaching from below. Okay, this is important because now I know that when I go to f of x, I need to approach from both sides. So when I do the limit for f of x, I'm going to be approaching 1 from the positive side. But when I do the other side of f of x, I have to approach 1 from the negative side. And I feel like we've looked at f of x enough to know at this point what is going on at 1. When you approach from the positive side, you get a 1. When you approach from the negative side, you get a negative 2. Again, when you have a composite function like this, you take care of this one first. G of x feeds into f of x. The values you get from g of x are the values that feed into f of x. The output of g of x becomes the input of f of x. So when I approach from the positive side, I get numbers that are slightly bigger than 1, which means that for f of x, I'm coming in from this side. It's going to give me a 1. When I approach negative 3 from the left on g of x, I'm still getting a 1, but I'm getting numbers that are slightly less than 1. I'm approaching from below. So that means that when I come over to f of x to check from the left, I have to approach from below. And it's going to give me a different value, so that's going to give me a big fat does not exist. Okay. I do know that these are a little crazy. It probably doesn't help a whole lot to just watch someone do them. You really, really need to try them on your own and then listen to the explanation or try to figure out where you went wrong by having the answer. I have also posted in the practice problems folder, there is a set of these that I snipped from a YouTube video of a guy explaining them. May help to hear problems like this explained in someone else's words. So I snipped the problems out of his YouTube video and put them on a paper for you so you can try them and then go watch his explanation to check your answers. Okay, thanks for listening to all of that. I'll see you for questions.